we have an induced electric field and we have 200 turns, 2000 turns per meter. And for the diameter of a solenoid is 4 centimeter. So we're just going to take the radius of this diameter, and that's 0.02 meter. For the frequency of the solenoid oscillates between 60 hertz. So that's mean we're going to use the angular frequency, and that's 2 pi times frequency. And then we have an amplitude of current is 2 amp. So we're going to use the formula that result of the induced electric field and with the strength of the magnetic field, and that's electric field from the inside is going to be equal radius divided by 2 multiplied by the change of the magnetic field divided by the change of time. Okay, so for the change, we know that the strength of the magnetic field is going to be equal constant multiplied by the number of turns multiplied by the amp by the current, and we know there's a frequency that goes with the amplitude of the 2 amps. So that's mean we're going to use the angular frequency, and that's amplitude equal the initial amplitude multiplied by the angular frequency. So it's going to be multiplied by the sine of the angular frequency multiplied by the time. So we're just going to replace this amplitude in the strength of the angular of the magnetic field. So the electric field equal the radius, that's 0.02 divided by 2 multiply by the magnetic field, and that's U constant multiply by number of turns multiply by the amplitude with the current with the amplitude with the angular frequency of the amplitude of the current, and that's the initial times the angular frequency times the radius divided by 1 second. So we're just going to enter the points and the information that they give us. So the radius is 0.02 divided by 2. Constant number of turns is 2000 turns. Multiply by the angular frequency, and you're supposed to have that's 2 multiplied by the pi and the frequency, that's 60 hertz. Okay, let's see. Multiply by 7 multiply by 60. We forgot this one is multiply another 2 here, and that's equal 0.0018 volt per meter.